We can move on to John next, talking about Project Pythia. Thank you, Marcus.
Okay, can you hear me okay?
Yep, we can hear you.
All right, let's see if I can screen share. All right, can you see my slides?
Yep, that looks good.
All right, terrific, thank you. So good afternoon and good morning, as the case may be. My name is John Clyne. I'm from the National Center for Atmospheric Research, and I'm going to talk to you today about Project Pythia, which is an open source educational resource for geoscience data analysis. And this is an NSF funded effort, and our collaborators, in addition to NCAR, are Unidata and the University at Albany. So the quick elevator pitch for Project Pythia. It is a community learning resource for geoscientists. Our aspirational goal, in fact, is to be the go-to resource for learning the scientific Python ecosystem. It is very much geoscience focused, so all of our examples and sample data come from the geosciences communities, climate, weather, and so on. It's intended to cover a broad swath of, I guess, abilities, everything from beginner, if you're just getting started with Python and the scientific Python ecosystem, to advanced usage, such as scalable computing with Python. There's a variety of different content formats, tutorials, videos, examples, and online courses. And then finally, it's a community-owned resource. The intent is not only that you use it as a geoscientist, but also that you might contribute back to this resource. So I'll drill down a little bit deeper. Project Pythia has two main components, the Pythia Portal, and which I'll talk about now. Basically, the Pythia Portal is a web accessible resource that contains all of our training material. Our training resources are primarily in the form of binderized Jupyter notebooks. So these notebooks are basically like executable textbooks, and I think you'll hear lots and lots about them throughout this workshop if you're not already familiar. But basically, you can download the Pythia notebooks and run them yourself, or you can share them, or you can run them in place through Binder. Again, as I said earlier, we have lots of sample geoscience data that you can use as part of our training material. There are tutorials, both online, that you can do at your own pace, or webinars that you can watch. Communication forums for not only reaching us, but as well as reaching others in the community. And then in addition to our own content, there are many, many links to external content that was developed outside of Project Pythia. To give you an example of some of the types of content you'll find at the Pythia Portal, again, there's introductory material that we refer to as Pythia Foundations, and I'll double click on that in a moment. There's also geoscience focused packages such as NetPy and GeoCat. And as I mentioned earlier, scalable workflows such as using cloud resources or Dask for parallel computing. So I want to say a little bit more about Pythia Foundations, which are what we believe every geoscientist needs to know to effectively use the scientific Python ecosystem. So in addition to a collection of well-known geoscience packages or geoscience-related packages such as Xarray, NumPy, and CartPy, there's also what I consider to be the pillars, I guess, of the ecosystem. Python, not surprisingly, but also Jupyter and GitHub. Jupyter because most of our content is delivered in the form of Jupyter notebooks, but also because so many in the geoscience community are moving to Jupyter to develop and run their own analytical workflows. GitHub, because not only is all of our content hosted on GitHub, but because we believe that it's really essential for geoscientists today to know how to effectively use GitHub for not only developing and sharing their own workflows, but also making use of other packages, helping contribute to those, or even just ask questions when you run into problems, or download these packages so that you can run them yourself. So the Pythia Resource Gallery, as I mentioned, not only do we have lots of our own material, but we also provide a landing place, I guess, for external material, training material that was developed outside of Project Pythia. And there's quite a bit of this, so we provide a means for searching and filtering. You might, for example, say, show me all of the content that uses Xarray and deals with climate data analysis, for example. And again, of course, you can contribute your own resources back to the Pythia Resource Gallery if you'd like us to link to that material. So coming soon, our work in progress are what we call Pythia Cookbooks. These are kind of targeted examples. They're I guess, collections of short recipes that demonstrate how to perform some particular analysis task. And I think our first contribution is coming from Max Grover, who gave the talk earlier today. And it will be on PyArt, using PyArt to plot weather data. Again, much like our external resources, we anticipate providing means to search and filter through these, as well as contribute your own cookbooks to Project Pythia. Okay, so I mentioned that Project Pythia really has two components, the Pythia Portal, which is all of our training resources, educational material. The second component is the Pythia platform. The Pythia platform are, more, I guess you can think of this as infrastructure, binder-like utilities that support interactive execution of Jupyter notebooks in the cloud. So the Pythia platform is intended to not only enable us to run our own educational material on targeted cloud resource providers such as AWS and Google Cloud, but also allow you to redeploy this infrastructure to facilitate your own binderized notebook creation and execution. Okay, so putting the two together, the Pythia Portal and Pythia platforms. Again, the portal is the visible component, I guess, of Project Pythia. It's the website and all of the resources, the training resources that you can search, filter, and download data sets and examples from. And then there's the back-end Pythia platform, which supports the execution of binderized Jupyter notebooks. The last thing that I wanted to quickly mention, open development. Again, Project Pythia is very much a community-owned resource and follows an open development model. The user community is not only encouraged, but expected to contribute in a number of different ways. Everything from simply providing feedback on the Project Pythia resources, but also helping us identify and develop content needs, or even helping develop new content, or identifying existing content for inclusion. All of Project Pythia is hosted on GitHub. And again, this is a kind of a key technology for enabling user contributions. And I expect you'll hear more about GitHub throughout the workshop. So to summarize, Project Pythia is a community-owned, web-accessible educational resource for helping geoscientists at all levels of their career become proficient with the scientific Python ecosystem. We really believe that the three pillars of the scientific Python ecosystem are the Python language, of course, but also GitHub and Jupyter. And then lastly, community engagement, again, is really critical for the success and sustainability of Project Pythia. So I encourage you to check out the site and please consider getting involved. I just wanted to acknowledge very quickly the Project Pythia community of contributors, especially the numerous technical staff that are doing the heavy lifting at NCAR, Unidata, and the University at Albany. So that concludes my talk, and if there's time, I'll take questions.
Great, thank you. Are there any questions out there? I will note that Max was able to give a tutorial on GitHub using some of the Pythia resources, and it's been a great resource overall to have. So I'm excited to see this. Are there any questions? Okay, John, how do you foresee the sustainable maintenance of Pythia beyond the current NSF funding you have?
That's a great question. Like a lot of open development packages, we're striving for sustainability that relies on contributions from the user community. And by hosting our material on GitHub and embracing an open development model, we hope, and we've had some success in attracting external developers, and we hope that we can continue to grow that community so that we can maintain a sustainable, I guess, volunteer workforce to help continue Project Pythia beyond the 3-year NSF award.
Great, thank you. I guess I have a question here as well, but it might be geared more towards Scott or Max from the ARM side of the house. So it looks like there's already some contributions planned. How do you see ARM utilizing or contributing to Project Pythia going forward?
It's a great question, Adam. Oh, sorry, do you want to go first? Do Did you want to have a go at answering that question first, Corey, or?
Yeah, I don't think that's so much a question for me as it is for
Okay.
perhaps the ARM people. So.
Cool. Yeah. And so for one thing, I just want to also say how much we like the project and how many folks we've actually directed towards that way. I really like the way the team has scaffolded it with the prerequisite lessons. So that is the first thing we'll definitely use Project Pythia for, is we will not be reproducing all of these, as they call them, the foundation materials. We're just going to use theirs. And with reference to, I kind of referred to these new workforce development activities. I think contributing to something like Project Pythia will be our default. That will certainly be what I'll be advocating for here, simply because, and I can actually put another hat on here as chair of the Python symposiums at the AMS annual meeting. In that role as well, I am trying to minimize the number of different organizations doing this, so that we can all kind of focus and coalesce around more things like Project Pythia as kind of a the workforce development go-to site for Python in the atmospheric sciences. Does that make sense?
Yeah. No, I think that's great. All right. Are there any other questions or follow-ons? But if not, thank you very much, John. We'll